Hey guys, this is Stefan and my part of our group project for a defense strategy against the bioweapon threat with Tularemia is to provide some background about the pathogen, the transmission, symptoms and treatments of the disease. Tularemia is a serious infectious disease caused by the bacterium Francisella tularensis. It's characterized by its ability to infect both animals and humans and is known for its variety of transmission routes and clinical manifestations. This bacterium can live both within and outside the host cells, primarily infecting macrophages and evading the immune system. In the US, tularemia has been reported in all states except Hawaii. The incidence and prevalence of tularemia can vary significantly depending on geographic location and environmental factors, which create conditions favorable for the survival and spread of the bacteria. The most important factors are aquatic environments, wildlife and rodent populations, climate and seasonal changes, vector populations, and, last not least, human activities that disturb animal habitats or result in close contact with infected animals, such as farming or hunting. The disease is primarily spread via vectors such as ticks and deer flies. Rodents, rabbits, and hares often serve as reservoir hosts. It can also be transmitted through direct contact with contaminated animals, ingestion of contaminated food or water, and inhalation of contaminated dust. Preventive measures include using insect repellent, wearing gloves when handling potentially infected animals, and ensuring food and water are from safe sources. Symptoms of tularemia can vary based on the form of the disease and the route of exposure and can therefore present in various forms, each with unique symptoms and modes of transmission. The ulceroglandular tularemia is the most common form. It typically follows a tick or deerfly bite after handling an infected animal, and of course, skin also forms at the infection site along with swollen lymph glands. There are other forms like glandular, oculoglandular, and typhoidal tularemia, which is characterized by a combination of general symptoms. However, the most serious form is pneumotic tularemia, which results from inhaling dusts or aerosols containing the bacteria. Most symptoms include eye irritation, sore throat, cough, chest pain, and difficulty breathing. Diagnosis of tularemia involving blood tests, biopsies, nasal and throat swabs, and pleural fluid tests. Treatment generally includes antibiotics like gentamicin and doxycycline. However, it's important to note that each form of tularemia requires specific medical attention due to varying severity and symptoms. Tularemia is considered a potent bioweapon for several reasons. High infectivity. A very small dose, approximately 10 organisms, is sufficient to cause disease. Aerosolization. Francisella tularensis can be aerosolized, making it easy to spread over a wide area and infect a large population quickly. Long-lasting illness. Infection with Francisella tularensis can cause a severe and prolonged illness, which can last from several weeks to months, potentially affecting a large segment of the population and straining healthcare resources. Environmental stability. The bacterium can survive for extended periods in various environmental conditions, making it easier to store and use as a weapon. Potentially fatal outcomes. While the mortality rate is lower with prompt treatment, untreated tularemia can be fatal, particularly its pneumatic form. Lack of effective vaccine. Finally, the fact that there are no widely available and effective vaccine for tularemia increases its potential impact of its use as a bioweapon. Thank you very much.
Hi, I'm Christy, and I'm going to be talking about current treatment options and the need for more diagnostics. Tularemia is harder than most other illnesses to diagnose, partly due to its rarity and also due to its shared symptoms with multiple other and more common diagnoses. Only around 150 to 300 cases have been reported annually in the USA in the past decade, or from 2010 to 2020. A patient may need to share with a clinician that they were bitten by a tick or deer fly, or have been around sick animals to set the provider on the right path. Because F. tularensis isolation is tedious to culture as well as high risk to lab workers, and detection of its DNA usually requires removal of infected tissues, serological techniques are most often used for diagnosis. However, these techniques are varied and poorly standardized. ELISA, microagglutination tests, and indirect immunofluorescence assays are currently the most frequently used techniques. they take 2 to 3 weeks to result. And the long-term persistence of anti-F. tularensis antibodies in patients with past tularemia infection decreases specificity with all these tests. Also, it can cross-react with Brucella and Yersinia as well as some others. Tularemia remains an underdiagnosed disease in most endemic areas, and the clinical presentations of this disease are still evolving. Since the pneumonic form poses the greatest bioterrorism threat, rapid diagnosis of this form is critical. Mortality is significant, 5 to 15% if untreated. If caught in time, though, it goes down to 1 to 3%. And as we said, streptomycin or gentamicin is usually employed. Hi, our company name is Surveillance Agents, and we're going to introduce a solution next.
There is a need for rapid testing of tularemia in the event of a biological warfare attack. TularEZ-DX uses sputum samples to test for the pneumonic form of the disease in the event of aerolization. However, due to the viscosity of sputum, the sample has to be prepared before being used on the direct lateral flow assay. These assays work by placing the sample at one end of the strip before moving to the conjugate pad, which contains antibodies conjugated to the nanoparticle for detection of the target analyte. The sample continues migrating using capillary action to the detection pad made out of nitrocellulose with biological components immobilized in lines. Their roles are to react with the analyte bound to the complex. Recognition of the sample is indicated by response at the test line, and the response at the control line indicates proper liquid flow. To prepare the sputum for testing, TPEC is used to break down the disulfide bonds that make sputum more viscous. Studies have found that 10 millimoles of TPEC have shown to increase the intensity of the test line and shorten the amount of time needed to run the diagnostic test. To help reduce the strength of the reducing agent, 7.5% PSA has been shown to help increase the intensity of the result when used with TPEC. During this process, the bacteria cells are also ruptured so the detector antibodies are able to form the complex. While gold nanoparticles are the standard in lateral flow assays, carbon nanoparticles have shown promise in lowering detection limits. This increases the sensitivity needed to test for pneumonic tularemia, as only a small amount of analyte is needed to give a positive result. Carbon nanoparticles are also relatively inexpensive to create and have a rich dark color when captured on the test and control lines. This is the methodology for creating the nanoparticle detector antibody complex that is on the conjugate pad of the lateral flow assay. The use of a dried conjugate pad helps with the shelf life of the product so that TularEZ-DX can be easily stored in the national stockpile to use in the event of a biological warfare attack.
The antibodies used in our lateral flow assay must have high affinity and specificity because the bacteria may be in low concentration in the sample. The reactions in the test must occur quickly since the detection antibody antigen complex must bind to the capture antibody on the test line in just seconds as it flows past. They must also recognize the antigen of interest, Francisella tularensis, and not other similar antigens. Choice of animal used to make primary antibodies is important for large-scale production. Since rabbits are hosts of tularemia, they do not make a good source of anti-F. tularensis antibodies. We would like our antibody-producing animals to be healthy and not exhibit signs of disease. We will use polyclonal antibodies where possible. Polyclonal antibodies are much cheaper and easier to make in large quantities compared to monoclonal antibodies. They're more sensitive since they recognize a wide range of epitopes, meaning more can attach and increase signal on the test. We will perform affinity purification of the polyclonal antibodies to minimize cross-reactivity. We'll start our R&D using the simplest case in which only 2 antibody types are needed. We'll generate polyclonal antibodies against F. tularensis in goat. These antibodies will be labeled with colloidal carbon and applied to our conjugate pad. They will also be used in a non-labeled state to form the test line. The control line will use rat anti-goat polyclonal antibodies, so they will attach to the anti-tularensis goat antibodies. This straightforward system will be our goal. However, if we encounter any issues with effectiveness that necessitate changes, we have additional options for a backup plan that will still allow us to create an effective and efficient test. In the most complicated system, we would use 4 different antibodies as shown here. The labeled detector antibody would be goat anti-F. tularensis, and the capture antibody would be rat anti-goat. An unrelated immunoglobulin is used as a control and is also labeled. This could be from chicken so that eggs can be harvested to collect the antibody from yolks. The control strip would contain anti-chicken antibodies, for example from rat. There are other variations between the simplest and most complicated cases utilizing different combinations of monoclonal and polyclonal antibodies, but in each case we would have a non-rabbit labeled detector antibody, a labeled control antibody, and capture and control antibodies that are painted in strips onto the membrane.
The economics. Tularemia will be manufactured in our startup biotechnology company, and the average cost for that has a desired burn rate of 20K times the runway of 12 months and the number of employees, which our company will have 10, giving a total of 2.4 million. Our lateral flow assay average cost would be around 30 to 100,000. The price per sputum container would be 260 per unit case, and each unit case consists of 500 containers. Our initial research and development costs will include IP, intellectual property, so our patents, copyrights, and trademarks, diagnostics reagents and materials, and what we need to calculate life cycle management. Our company has a biosafety level 2 in-house lab. Purpose for that is it will give us quicker time scale of iteration and higher consistency in our experiments. As previously stated, we are a 10-person company, so it consists of business development, technology experts, engineers, doctors, technicians, financial officers, QA, and production. How we will verify our rapid lateral flow assays is using technical transfer, so batch manufacturing and documentation, which will ensure reproducibility, robust assays, and guarantee quality standards. Why invest with us? We are looking for further funding from U.S. government to stockpile our lateral flow kits. Your investment will help the United States respond quickly in case of a bioterrorism threat to tularemia. And given this extra funding, we will be given extra resources, space, and money to be able to provide a high throughput production of these assays. And what's great about our assays is they can do large scale testing, quicker results, cost effective, they're simple to use and do not require additional equipment, have a long shelf life, which is great for stockpiles, and they are portable.
To conclude, there are no tularemia tests commercially available in the United States, so our Tularemia DX test will fill a void in bioterrorism testing. It's designed to test for a disease from inhalation exposure since an aerosol is the most likely mode of delivery in a bioterrorism event, and it will identify the resulting form of disease, pneumonic tularemia. This is also the most serious form of tularemia. Our team of scientists at Surveillance Agents have a proven track record of developing successful and effective diagnostics. And finally, we will market this test to the federal government for inclusion in the Strategic National Stockpile. The stockpile was designed for public health security and bioterrorism preparedness, and the Department of Health and Human Services has prioritized preparing the Strategic National Stockpile to respond to low probability but high consequence bioterrorism attacks. As such, we anticipate a generous return on your investment. Thank you for your time and consideration.